let's start. Please be quiet. I'm Professor Gu, Zonghua Gu. I'm the instructor for this course. A few of you sent an email about the class quota. It's been increased. I hope most of you are able to register, right? So that's my office. My office hours are after class, 3 to 5, or by appointment. I have an open door policy, so if you can drop by and catch me, I'm always glad to help with your questions. So, grading, obviously, this is the most important part of the course. So, we have 10 lab assignments. The lab assignments are done with the TAs in the lab, where you're given the problem and you try to solve it in the lab. So, it's 20% of the grade, 2% for each lab. You may have old lab assignments and solutions, but this semester's assignments will be different. So don't just copy previous answers. It's not going to work. Midterm exam, 50%. The date is wrong. I'll fix it. It's sometime in May. It's called, I'm sorry, it is in April, but not April 12th. So it's called midterm, but it's really a very late midterm. It's almost like a final. So after the midterm, there's really no more class presentation classes anymore. You have project presentations after the midterm. So you focus on your projects. So project and presentation are 30%. Should be 3 lectures, because this course used to be 2 lectures per week, 1 hour each. Now this semester they changed it to 2 hours per class and 1 class per week. So last 3 lectures will be dedicated to project presentations. So the lecture is 2 hours. We'll take a break after 15 minutes and continue for another 15 minutes. So the project, you will devise, implement, and document your own custom application. You choose your own topic. Includes Unix. As long as it involves Unix shell scripting or Perl, it's fine. You can write a shell script, custom application, Perl script, or Perl CGI application, or your own server client application. So all these keywords will become understandable to you as we go on in the course. So you'll work in the groups of normally 4 people. But if you feel that 3 or 5 work better for you, then it's fine. More people doesn't always mean less workload for everyone, because you need to coordinate among the group members. So I will assign the groups later in a few days and post it on the website. So I generally don't allow you to choose your own group members, because it will be a huge headache for me to accommodate everyone's request. So therefore, you need to learn to work with others, even though you never met the guy before. So presentations will be in the last 3 classes of the semester. The format for the project presentation is a 7-minute presentation plus 3 minutes for Q&A. Presentation includes a demo of your software. By May 7th, you send me by email your PowerPoint slides and a short paper describing your system, summarizing your presentation, and any source code of your project. This is the course homepage. An easy way to get here is to Google my name and find my homepage. I have a link on the homepage. So just Zonghua Gu is my homepage, and I have a link in the bottom. So we have a news group which has some old stuff here. But I encourage you to post questions and any discussions on the news group so that everyone can see your answers, see the answers. But you can also send me email. I will generally post the emails and answers on the news group as well, taking off the names, of course. So these are all the lecture slides. There's no official textbook. These two books are recommended reading, but to pass the exams and work on your projects, you don't have to read these books. You can just follow the lectures material, that's fine. But if you want a deeper understanding of the subjects, you may want to get a copy of the books. So I have a column called quizzes. These are really not quizzes because I don't let you work on it. I'll just discuss the answers in class. And then the labs will be posted as the semester goes on. The labs are, you have 3 sections in the same labs, same room, 40 to 14, at different times. So each of the TAs will be responsible for the, say, Lin Xuanyuan is responsible for labs 1 to 5, and Dong Lin will be responsible for labs 6 to 10. So, and the TA's office hours will be 1 hour after the lab. So, therefore, so if you have labs from 4 to 6, then the office hours will be 6 to 7, so you can ask the TA questions after the lab. So all the TA's emails and contacts are in here. So feel free to send email for any questions on labs to the TAs, and for any questions on the lecture material, send email to me, or post on the news group. So the schedules are posted here. Midterm is on the 17th in the evening. So it will cover the entire lecture material. And then presentations are the last 2 weeks. These groups will be updated to reflect this semester's grouping. So that's the website. Okay. Okay, are there any questions on the course statistics? Okay, so good. Right. I wanted to show you something else also. In the bottom of the course website, I put a link on past projects, where I collected a few projects from the previous semester. Of course, no source code, only the websites. Most of them are games, so maybe it's a good idea to develop some kind of game. See, bomb sweeper, where you can select number of rows or columns. You know the bomb sweeper application in Windows, right? You sweep bombs, and if you hit a bomb, you die. So you can develop one by yourself. And memory card game. So actually, I don't know how these are played, but in any case, you can look through them to get some hints on your own project. So the links is right here. It's past projects at the bottom of the page. So all these are plagiarism, integrity, you know all that. So I'll skip all that. Okay. Let's dive into the course. So the main topics include Unix, shell programming, Perl, regular expressions, web programming with HTML and CGI, and the servers. So that's the main topics of the entire course. So we have lectures, exercises, and quizzes. So what is Unix? Unix is an operating system. We have the operating system course 252. But it's talking about the internals of the basic fundamental operations of the operating system. But this course is really about the surface, the externals. That is, how do you use the operating system? You don't care how it's implemented inside. You just use this interface to develop your own programs. So, operating system is a control program that helps the user communicate with the computer hardware. So it is a layer of interaction, layer of abstraction that hides the hardware complexities from the human user. The most popular operating systems, of course, every one of you uses Windows from Microsoft. It's the Big Mac of operating systems, cheap and billions served, because there's an advertisement slogan from McDonald's for the Big Mac. It says billions served, right? Billions of Big Macs served. Windows is also very popular. But Unix was developed long before Windows. 36 years ago at the AT&T Bell Labs in the US. So Linux, as you all know, it is Unix for PC. So when Unix was originally developed, it was designed for large workstations, and on the PC there's only Microsoft Windows or DOS. But later, Linus Torvalds, this inventor of Linux, really ported Unix to PC hardware that is called Linux by his name. So Unix is an operating system for experts used in high-end workstations, database servers, and web servers. So it is not as user-friendly as Windows. You need to type in commands. Even though there are graphical user interfaces available today, it's designed really for expert users. That is for system administrators, for computer science researchers, etc. So it provides powerful features like security, private and shared files. So for each file, you can set permissions as to who can see it, who can modify it, whether it's shared or private. Multi-user support. That is, multiple users can share a Unix computer simultaneously by logging in to the computer, perhaps remotely, which is not very well supported by Windows. Windows is generally a single-user system. If you remotely log into a computer, then you control the computer exclusively. No one else can use it. But Unix is different. You can have hundreds of users logged on at the same time, use the hardware at the same time. So data sent to display files and printers in the same way. It means that all of these devices, like the LCD display or printers or files, they look the same to Unix. They are in the form of files within some directories. If you send the data to the file, if the file happens to be pointing to the display, it goes to the display. If it happens to be pointing for a printer, it goes to the printer. So it's very uniform I/O model. You'll learn this very quickly in the course. So it's a very elegant, uniform way of treating all the I/O devices. Inter-process communication. So Microsoft keeps trying to upgrade Windows to try to replace Unix as the OS for experts. So we have Windows XP and Vista for client, Windows Server, Exchange Server is the email server from Microsoft, and other database servers, SQL Server, etc. for the servers. They are making some progress, obviously, but for really large server farms used in the backends of large companies like Google, their server farm is running Linux because of many reasons. First, Linux is free. Second, it's very stable. It doesn't crash often. Third, it's open source, so you can customize the file system, customize the OS for your own particular needs. While Windows is closed. So there are two main types of Unix. One is BSD, Berkeley Software Distribution. One is System 5, developed at AT&T. So that is, originally it's from the Bell Labs, and Berkeley had a version later. So they had kind of these two forks, two branches of Unix. So we cover Unix System 5, but it's pretty much the same. Most of the commands are the same, including Linux. So everything we do here also applies to Linux. So many different versions of Unix for different hardware. Linux for the PC, including many variants. Mandriva is running on CSLab 2. Red Hat, Fedora Core, and Debian. So they are based on the same core Linux source code, but they are really had some customizations by different companies who provide support and a service for Linux. So say Red Hat is a famous company, Linux company. Linux is free, right? You can't sell Linux, but you can sell service and add-on software. So Red Hat is very successful in customizing Linux for its own with its own version and then supporting it by providing paid support to companies. Sun Microsystems Solaris is a version of Unix running on Sun's hardware. So Solaris is a an Italian word for sun. Hewlett-Packard has a HP Unix, and IBM has AX, SPI has Arix. They're all variants of Unix by porting Unix to their own particular hardware. So who uses Unix? Perhaps not on most laptops sold in stores, but they're used in big companies. They use Unix especially for servers due to its stability. You can afford to hire employees with Unix experience. Like computer manufacturers like Sun, SGI, IBM, HP, Motorola, Intel, chip manufacturers, software companies like Hang Seng Bank and the Hong Kong government and others, hospital authority, universities. So Unix is more widely used in the back-end server market than in the front-end client market. You may not see it very often in your daily life, but it is very popular. So small companies use Linux for its low price, that is 0. Especially if you're developing small PDAs devices, and each unit is supposed to sell for you're supposed to sell millions of copies of your devices, then having a free OS really helps you to save costs. So most important feature of Unix is its stability. They have 36 years to get the bugs out. So all the source code is open and free, so you have 36 years for the open source community to work on it and squeeze out the bugs. So this is important for shared environments and critical applications. If a computer server goes down, it affects hundreds of thousands of users. But while if a client goes down, it only affects one user. So it's especially important for in a server environment to have stability in your OS. Shared environments example are universities. So Windows crashes 1 or 2 times per month in the labs. From the statistics, Unix servers crash usually only when hard disk fails. Therefore, it's more reliable than Windows. So I generally have to reboot my workstation, Windows workstation, at least a few times per week. Otherwise, some weird, strange bugs happen. So critical applications include banks. You don't want to lose money in ATM transactions. If you're doing a transaction and your computer crashes, obviously that's a critical application. So hospitals, you don't want to wait to reboot during operation. Airport, aircraft control, landing airplanes, and PCCW don't want phone systems to go down. These telecom companies often want their system to be up 5 nines or 6 nines, which means that it needs to be up 99.99% of the time. So Unix has a long, rich history. If you're interested, you can go into these links to see the key players in Unix and how it evolved over the years. These are the key persons. Bill Joy is used to be a son. Now he's moved on to a startup company. Steve Jobs, you associate him with Apple, but he was also instrumental in developing Unix. By the way, Apple's operating system is based on the Unix core. That's why Apple is generally more stable than Windows, actually. Linus Torvalds is the inventor of Linux, and Richard Stallman is this open source movement leader who visited HKUST a few years ago. Key persons are Ken Thompson and Dennis Ritchie. They won the Turing Award, which is the highest award, Nobel Prize for Computer Science, in 1983, for the development of generic operating systems theory and specifically for the implementation of the Unix operating system. So just a brief history. In the 60s, they had its operating system called Multics, Multiplexed Information and Computing Service Operating System. It's called multiplexed because it allows multiple users to share the computer at the same time. While in the old days, the computer is for use by one person at a time. It's not shared. So AT&T Bell Labs, Thompson and Ritchie are all there. They developed these Multics, and then they evolved in name to a Unix, and then eventually they removed to last CS into X to Unix. So in the 1970, they have this Unix OS running on the PDP 1120. This is the very old computer model. 73 is written in C. 76 is first licensed release, version 6, and 77 is a Berkeley distribution. 78 is the first portable version. That is, portable means that you can run it on different hardware. 79 is Berkeley standard distribution. 83 became System 5 became industry standard. 86 you have BSD. 93 Linux was developed by Linus Torvalds for PC hardware. The image of Unix is elite, which means that it's not for your average grandma. It's for computer literate persons. Free spirit plus creative. That is, the source code is open. Anyone can innovate based on the source code, and you can customize everything. Customize your file system, customize your scheduler, do anything you like with it, so you can be creative with it. Stable and secure. It's stable because it very rarely crashes. It has very few bugs compared to a Windows. It's secure because it has very good protection, even though it's shared by many people. You can perhaps see a few files in other people's directories, but the permissions are set carefully so that it's very secure, despite all the sharing. It's open source, so I actually attended one of the Linux conferences organized by an organization called Usenix, which is a computer organization focusing on open source software. It's interesting to see that all the laptops are running Linux. Well, I'm the only guy there with a Windows laptop, and I felt out of place. So the philosophy of Unix is minimal design, simplicity. Keep it simple, stupid. KISS. KISS principle is this word This sentence came from a U.S. Presidential campaign slogan: "Keep it simple, stupid." So this is not trying to be insulting. This is just a commonly accepted proverb to keep things as simple as possible, but not too simple. Simple is beautiful. So by simple, we mean that the underlying design of Unix has very few primitives. You learn as you go on in the course that there are a few basic commands, but you can use them as that Lego blocks to build your own sophisticated commands and programs later. So unlike Windows, which is very complex, and everything, you cannot customize it, and everything is built for you. You can only use it. Well, for Unix, you can play with the basic principles and design your own higher level system based on it. Do one thing and do it well. And open access. That is, source code is always open. So technically, Unix is a simple, coherent system which pushes a few good ideas to the limit. So we will see one of the good ideas is pipes. So what are pipes? Pipes allow you to flow, have data flow from one command to another and then to another. It's like a pipe of water that flows through a bunch of commands. This allows you to tie up many commands together into a larger system. So there are a few very good ideas. Unix is simple and coherent, but it takes a genius, or at any rate a programmer, to understand and appreciate its simplicity. So it's simple once you get to know it, but it may be intimidating at first when you have to learn all the basic commands first. So that is the basics. So we'll discuss Unix utilities. So the machines in CS Lab 2 are named CS12 Work 01 to 41 workstation. CS12 WK01 means CS Lab 2 workstation number 1. Full machine name is this. So I assume you know this program called Secure Shell, SSH. I think it's on all the workstations, and you can install it on your own computer, laptop. So you can work on Unix from home. You can use SSH to connect to the Linux or Unix workstations in the lab. So if you know these machine names, just connect to it with your account. I think everyone here should get an account on these machines. And also, any machine is interchangeable, so you can connect to any one of those, and your account will work on all of those. So, Unix file utilities, these are the basic commands. ls lists the files in the current directory. Directory is this another word for folders. Folders perhaps is more intuitive. Directory is like a phone directory, right? You look up someone's name in the directory. If you learn the internals of the file system, you'll see that a folder is really like a directory. It stores all the locations of the files in that folder. So it's also called a directory. For now, just remember, directory equals folder. Cat display file. So I have a picture of cat here. So cat really means catalog, so it means to display something. More means to display one string of file. So if you have a long file, if you use cat, it'll fly by and only display the last page. But more allows you to display one string, pause it, and then display another one. Remove RM removes the file, and copy CP copies the file. It sorts into a target file, overrides the target file if the target file already exists, and creates a new file if the target file doesn't exist. Move, rename, or move a file. By the way, if you use DOS, there are some commands that are similar to this, but they use different names. Say RM in DOS is del, delete. Move is called rem, rename. So LPR, print a file. LPR means line printer. It's because in the old days, printers are line printers, and it prints one line at a time. It goes one line at a time. It's very slow, but the name stuck, even though we now have laser printers. Man prints help manuals. If you are not clear about the usage of any command, you just type in man command name. Say man ls tells you how to use ls. And mpage prints multiple pages on PostScript printer. It is not a standard Unix command, but it's available on most Unix systems. So a PostScript printer is again this old terminology where the information sent to the printer is in the PostScript form, but the name is no longer used, but the command is still there, mpage. So I hope it's large enough. So this is my home directory. Now I just need to change directory to 111, which is my working directory right now. So ls lets you see all the files within this directory. You can do ls -l to see the details of the files. I think it's too large. Let me try to still too large. 24 maybe. Okay, so that's better. So you can see we have 4 files. It says total 8 because there are some hidden files we'll learn later. These are permissions. We'll discuss these permissions later. And this is username, the guy VGU, who's me, who created these files. These are the date and time when it's created. And this is the file size in terms of bytes. So ls displays the files and direct subdirectories within this directory. So letter 1 is a file, secret is a directory with a slash in the back, which means that it may contain other directories or files. So depending on different Unix versions, some versions will give you a secret slash to indicate it's a directory, but in my version, I don't have a slash in the back in the back of secret, but I know it's a directory. You do cat to see what's in the file, So you all heard the story about Bill Clinton and Lewinsky, right? So this is just a joke as to this Lewinsky is getting late, please order some pizza and come by my office, etc. So that's the content of the file. Now if you do a copy, letter 1, letter 2, this command means that you copy content from letter 1 into letter 2. That is, its direction is from the left one to the right one. Now, if you do ARS, you see letter 2. So you can all see the letters, right? It's not small, not too small. Okay. And then you can see letter 2 as the same comment you had in letter 1. So and you can do move if you do a move letter 1, letter 3, then the letter 1 is gone because you deleted letter 1 and moved all the contents into letter 3. So you can do a LPR to print letter 2 with dash P, which means the CLL2A is the printer name. Or you can do MPage to print letter 2. You can remove letter 2, and then you are left with letter 3 only. So you can do a man on any command. So you do man ls, it'll give you a name, synopsis, description, and how you use it. So Unix shell listens to what you type and executes commands at your request. So Unix kernel. So kernel means something in the center of things, right? Kernel of a peanut is this a peanut inside the shell, right? Shell is the thing outside surrounding the kernel. So Unix kernel is connected to the printer's files and memory, etc. So it's hidden from the user. The user sees the shell. User is sitting on here, facing the screen. So the shell interacts with the user. User issues commands like LPR, like ARS. The shell then uses the command library, all the commands, and sends the command into the kernel, and kernel sends the result or status of the command back to the shell. So in 252, in operating system, you learn about the kernel. But in this course, we don't care how the kernel is implemented. We just focus on the shell. So you can think of the shell as the user interface. So there are several popular shells. Bourne shell, the original shell, SH, stands for shell. C shell is designed for really by borrowing some ideas from C programming. That's why it's called C shell. TC shell is the newer C shell. This is wrong. This is TC shell, not TSCH. So it's like C shell, but with more functions. So anything that works on C shell also works on TC shell, but there are some enhanced commands on TC shell that's not available in C shell. It's the default shell in the labs. Bash shell is this Bourne again shell, which is an improved version of the Bourne shell. And Corn shell, these are all named based on people's names. It's a new Corn shell. Z shell So all the basic commands like ls, like rm, like copy, they all work on different shells, but each shell has its own custom commands. So we have TS shell in our labs. How do you find out which shell you're running? So you do a PS, which displays all the processes in the system. You see, I have two TC shell commands running, which means that I'm logged on to the same machine on my desktop computer in my office. That's why you see two processes here. And also, you can always change to another shell just by typing the shell name. C shell, you go into a C shell. If you do a bash, you go into a bash shell. So you can always change it. By the way, anything that's not on the slides will not be in the tests. So I may discuss some things outside the slides, but you don't have to memorize any of those. So finding information, who shows who's logged on, where and when. So if I do a who here, I see many people are logged on. These are the user names. These are the terminal, which terminal is logged on. So PTS 35 refers to this particular terminal on this particular workstation. PTS 33 is the terminal open on my machine in my office. And when I'm logged on, February 6th, 9 a.m., that's this morning. And this particular connection is February 6th, just a few minutes ago. An hour ago. So this is the from where you're connected. cr2306.usc.hk is the IP address of this particular computer right here. So I'm connecting to a remote computer called RAS, which sits somewhere, I don't know where actually. I only know the name is called ras.csc.ust.hk. So I'm connecting it to it from this particular computer here in this room. And my other connection is from my desktop workstation called CSE 660. So you can do a finger to show a bit more login information. So for example, here you can see how long he's been idle, and when did he log on, what time did he log on, what's his office, and what's his office phone number, if he has this information. But if he doesn't have this information stored in his home directory, then you cannot see his office and office phone number. You can only see what information this user puts up in terms of the rest of the information. So you can finger a particular person as well. Say if I finger myself, I can see my login name. In real life, my name, my shell is bin tc shell. My directory is this, and when did I log on since February 6th is much, and mail last read is February 5, 2009. So this because I don't read this Unix email regularly. I use another mail client. And no plan, which means that I don't have a .plan file. So if I create a .plan file, and then do finger again, no plan. So did I do that right? Anyway. Anyway, Finger allows you to get more information about its particular user. So write is send message to another user. So you can do a who am I to see what's the current who am I who's logged on right now, and then you can write with another person's username. Say write Clinton, you can type in a short message and hit Control-D to send the message. And on the other computer, so this is on one computer, this is on another computer, where say who am I Clinton, then Clinton will see, because you write Clinton, Clinton will see this message popping up on the screen if he happens to be online. So this is now we have more sophisticated short messaging programs like MSN Messenger or ICQ. They're all based on the same idea, except write is a really old version of the short messaging program you're using now. So Echo display command line input to the screen. So anything that's after Echo gets printed on the screen. So Echo, hi, I'm Bill, and she's the boss, and it'll display the whole thing after Echo. And Dave prints the date and time. So I think I'll push on and finish the lecture early instead of taking a 10-minute break. Is that okay? Good. So head displays first few lines of file. So head -2 means that you display the first 2 lines of letter 3. And tail obviously displays the last few lines. Tail -2 means you display the last 2 lines of letter 3. Grep finds a pattern in the file. So grep sum pizza letter 3 means that you find this particular pattern sum pizza in the file letter 3. So it'll grab this particular line with the word some pizza in it and put it on the screen. So it's really like in Microsoft Word where you do find, right? And you type in a word to look for in the file, but it's really more powerful because we'll learn about regular expressions later. So you can specify perhaps not just some pizza, but perhaps a word that starts with a P but ends with a Q and doesn't have an L in it. You have complicated expressions of the expression of the pattern. You don't have to have an exact pattern to do search, which is not available in Word. Sort the lines in lexical order. That is in alphabetical order. So sort letter 3, if you recall, letter 3, you have 6 lines in it. And then sort orders the lines based on the first letter. So Bill is the original line, last line. Because it starts with a B, you put it in the top. And by my office, by It's a small b, which is after the big B. And you see the 6 lines reordered in terms of the first letter. So, and sort-r is a reverse sort, where you place in reverse alphabetical order. Notice that it's by lines, right? It's not by word. So you're not sorting by word, you're sorting by each line. Each line ends with a termination symbol. That's the slash. That's the backslash n. If you write C programs, you know printf something backslash n, which means it's a new line. So that defines each line. Unique display file with duplicate adjacent lines removed. So suppose you have this file names, you do a cat, you see the content. You have 5 names in it, each one occupying 1 line. But Bill Gates is duplicated. You have 2 Bill Gates in there. If you say unique, you remove the duplicate and only have 4 unique names in there. Again, it's line-based, not word-based. You can still see that you have 2 Bills, Bill Gates and Bill Clinton, but it's okay because they're on different lines. And the next word is different, so these 2 lines are different. Only when 2 lines are identical, then you remove 1 line. So I/O redirection is a very elegant, powerful concept for I/O in Unix. So you have standard input. On Unix, it's the keyboard, and standard output is the display screen. So any command you type in, if it needs any input, it waits for you to type in the data from the keyboard and displays the sorted data on the screen, display the result on the screen. So say the command is sort. And any command needs some input and provides some output, right? So it takes input from the keyboard, which is the standard input, stdin, and places the output into the display. So you can replace the standard and standard outputs by other things. For example, you can redirect the output to a named file using the greater than command. It's like an arrow. So this command here means that sort names and place the output into names.sort. So let's look at this part only and compare it to the previous one. Here you have input from the keyboard and output to the display. If you don't say anything on the command, just type in sort. Then you have standard input as the keyboard and standard output as the screen. But here, if you type in sort names, it means that you place the standard input as the names file, a file whose name is called names. And you have arrow names.sort, which means that you replace the standard output, replace the screen with a file called names.sort. So now instead of typing input from the keyboard, you take input from a file. Instead of displaying the output to the screen, you display output, place it in a file. So now if you type in this command, nothing happens. Why? Because now the output is no longer to the screen. That's why there's no output. If you don't have this redirection, then the output is to the screen, so you see the output, right? However, now because of the redirection, you have a new file called names.sort. So, and then you can, if you're typing another command, unique names.sort, notice that what happens here. Similarly, unique is another command, and it takes as input the file names.sort with this command, and the output, because you don't have a redirection in the end, is the default, is the screen. So you see this display on the screen. So what happens if you do a redirection? Then it's no longer to display on the screen, but you can see that it's in the file. So that's what I said before. In the beginning of the lecture, Unix has these powerful features. That is data sent to display files of printer in the same way. So you can replace the display with a file, or replace the file with the printer. So it looks the same in terms of the command, but it has different effects depending on where you send the data to. So, any question on the I/O redirection? So, another redirection is the left arrow or less than to redirect input from a named file. Because this is so common, we do this as the same as the left redirection. So, so you can omit this left arrow and have the same effect as redirecting the input. And you can have both input and output redirection together. So what does this mean? This means that sort is a command taking as input a file called names and producing output to the file called names.sort. Of course, you can remove this less than without any effects. So you can also okay, sorry. So another key concept is pipes. So standard output of a program can be piped into the standard input of another program. So here, look at this command, sort names pipe unique. So remember, sort names is equivalent to sort arrow names. And then it produces output, right? Now, the output is piped into another command's unique. And then finally, unique produces another output, which is to the standard output. If you don't specify the right arrow redirection, then it's always to the display. And then unique display sends the output to the display as the result of sorting the names and then running it through unique. So names flows through these two commands in order, and then finally output comes out here. So let's look at what happens at certain names. You have Bill Clinton, Bill Gates, George W. Bush, and then you pipe it to unique, which means that you instead of printing the output of these 5 lines on the screen, you put it in as input as the unique. And then unique produces the output to the screen, to the display, by removing all the duplicates. So you can achieve the same effect by placing the output of sort names into a file and then have unique read that file as input. But this pipe command is more direct. That is, you bypass any file, intermediate files, you just directly link the output of one command into the input of another command. So you can have several pipes connected, so have a few pictures of pipes. So catch names produces output 5 lines. You pipe it to sort, which sorts it, and then pipe it to unique. And then, so the result is the 3 lines here. And also you can pipe it to unique first and then to sort. You get the same result. Pipes and I/O redirection can be used together. So sort -r names sorts the names in reverse order, reverse alphabetical order, and then send it to a unique as input, and then unique's output is redirected from display to the file name.rev. So now if you type in this command, you see no display on the screen. But this new file is created. You can see what happens, what's contained in the file. So always remember that pipes and the redirection, they may be similar, but anything after a pipe is always a command. Anything after a redirection arrow is always a file or a printer or display or any device that you want the output to be. So any questions on this material? You should type in these commands yourself after class and play with these pipes and I/O redirection. So we'll go over the quiz questions now. So what's wrong with this following commands, copy file 1, file 2? So the answer is that it should be CP, not copy. what's wrong with this command, rm file, save file? So Unix is case sensitive, so you must have lowercase. All commands are lowercase. It'll give you rm, big rm, command not found. File names are also case sensitive. So you have a dot, if you have a big FILE, it's different from the small FILE. This is different from Windows. On Windows, all files are not case sensitive. File names are not case sensitive. So what's wrong with this command? Copy names it and pipe cat. So this is what it's doing is that it's executing this cp command and copies the contents of a file called names into another file called it, so a new file is created. And then you pipe the result into cat. The problem is there's nothing to pipe. There's no input. So copy, when it's done, it's done. It doesn't produce any output, right? If you have ls names, then you have output. No, if you have cat names, you have output that's supposed to be to the display, and then you can pipe it to another command. But for this cp command, there's nothing input to the cat. So always remember that if you remove the pipe, you should see something on the screen, on the display. And then it makes sense to pipe it to something else, to another command. If you see nothing, even if you don't have the pipe, then you add a pipe, then the pipe will do nothing. So what's wrong with this command? So unique, this is actually wrong. This should be a less than. So it's essentially saying it is a file. You provide it as an input to the command unique, and then you do this. So this is syntactically wrong because you cannot do less than certain names. It has to be less than file name. That is, think of the files as nouns and commands as verbs. So anything you like to redirect, it needs to be a file, not a command. So what's wrong with this command here? Unique letter 1, pipe search less than name. So what it's trying to do is trying to provide letter 1 as input to the command's unique. What happens? You get an output as sorted version of letter 1's contents and printed on the display. Now, on the right, you have names. Names provided as input to the sort command, and then you should have sorted version of the name's contents. But now sort has two inputs. One from the pipe on the left as the output of the unique contents of letter 1. On the right, you have names as another input. So this is wrong. A command only has one input. So you have either left or right. You shouldn't have both. Let's try it out. So let's see. Unique letter 1. Oh, I moved it. So this is the same as redirection. With or without the left arrow is the same effect. So I see these 5 lines. Actually, unique doesn't do anything here because letter 1's 5 lines are all different. Okay. So if I pipe this thing into sort, then it's sorted, starting with Bill, and then it, and then MS. So that's the same line. Let's see. I think the font is too big, so some things are wrapped around. So here in all the capital case letters are ordered before the lowercase letters. So big B is the first line, big I, IT is the next line, and MS is the next line, thanks is the next line. So this is fine because unique takes as input the contents of letter 1, the file, and then it pipes the output to sort. Now, what happens if you type in this command? Letter 1 sort names. It's supposed to give you an error. Let's see. So sort names gives you the sorted version of names, and I think it's a different shell. That's why it's behaving differently. Now I have TC shell and see what happens. Yeah, ambiguous input redirect. This means that the sort has 2 inputs, one coming from the left, from the pipe, another one coming from the right, from the file called names. For some reason, when I use bash shell, it actually doesn't give me an error. So it shows you the slight differences among different shells. So now I'm using TC shell, it gives you an error. Question? Well, because less than is can be always omitted. So it's the same. Greater than cannot be omitted, but less than can be omitted for convenience, really. If you put in less than, it's more clear. So what's wrong with this command? Unique letter 1. So now you see you don't have a less than, but it's the same. Unique letter 1, it means that letter 1 is the input to the command's unique, and then the output is redirected into the file called IT. And then on the right you have sort and redirect the output into IT1. So now the intention, I believe, of the writer is to try to get unique content of letter 1 and pipe it to sort and place the eventual output into IT1. However, he does it wrong because you have two outputs from unique. One is to the file called IT, another is to the pipe into a sort. So let's see. Unique letter 1, type it into IT. So this is fine. Let's remove IT. So this command is correct. What happens is that so this is equivalent to this, right? So you have unique. You redirect input from the letter 1, and you get the unique content of letter 1 and redirect the output to another file called IT. Now, IT contains the unique content of letter 1, which happens to be the same because there's no duplicate lines in letter 1. Now, if you want to sort it, you can do this. So this is saying, okay, input is redirected from letter 1, output is redirected into a pipe to the input of sort command. And then the output of sort is going to the standard output of display. So now you'll see the sorted version of the letter 1. And you can also redirect the output. Instead of to the standard display, you put it in IT1. So now you can see IT1 has this content of the sorted letter. Now up to now, everything is fine. But if you do this as the example here, it gives you the error message says ambiguous output redirect, which means that you are redirecting the output of unique to a file at the same time as to a command input of sort, which is not allowed in this shell, at least. So you can achieve the same thing as, say, you can do two commands: unique letter 1, place it output into IT, and then you can redirect input of sort from IT, place the output into IT1. So now you can see IT1 has this correct content. Or you can do unique letter 1 pipe it into sort, redirect to IT1. The file exists. Otherwise, it'll also put the content into IT1. So you can see I did this in two different ways. In the first way, I used this intermediate file, IT. I placed the output of unique into IT and use it later in another command as input to a sort. In this command, I bypass this intermediate file. I just directly go from the output of unique into the input of sort. Both have the same effect. Obviously, this with pipes is more elegant, right? You don't have an intermediate file to store and to read. But what you cannot do is to have this command, right? You have both outputs redirected to IT to a file, and then at the same time redirected into the pipe to another command. That will tell you ambiguous output redirect. So remember that when you're composing commands, always each command must have exactly one input and exactly one output. If you don't specify the input, it's a standard input from the keyboard. If you don't specify the output, it's standard output to the display. But you cannot specify true input or true outputs. So that's the spirit of the last two questions. You can play with these commands after you get home. Okay, so that's it for the lecture. Next week, the labs will all start. So go to your lab sessions. You remember these are graded. Labs are graded, so you must go to your corresponding lab sessions. Okay, see you later.